Hello, yes, and welcome to our 5.2 notes, our second set of notes for Unit 5, where today we're going to introduce matrices. And we're going to work with matrices a bunch this unit, so it's important that we have a pretty good understanding of some of the basics that go into it. So a matrix is a rectangular array of values. A rectangular array of values. And I have an example here. It's a rectangle where we're going to use rows and columns, and all of these A's just represent different values, okay? Now the plural of a matrix is matrices, so we're going to be dealing with matrices this unit. A matrix that has m rows, so rows are the vertical, and n columns has the order m by n. All right, so m represents the number of rows, n represents the number of columns. Now, if m equals n, that is to say the number of rows and the number of columns are the same, then we say it's a square matrix of order n. So if m and n are both 3, we'd say it's a square matrix of order 3. So here's some examples of matrices, and we're going to start just by stating the order. So looking at letter A, 2 rows, 2 columns, this would be 2 by 2. And that's all we're doing. Letter B is also 2 by 2. Now looking at letter C, there are 2 rows but 3 columns. So this would be 2 by 3, same as letter D, 2 by 3. Looking at letter E, this one has 3 rows and 2 columns, so the order of this one would be 3 by 2. Same with letter F, also 3 by 2. Looking at letter G, 3 rows, 3 columns, so this would be 3 by 3. Letter H is also 3 by 3. Now looking at letter U here, this has 2 rows, 1 column, so this would just be 2 by 1. Looking at letter V, also 2 by 1. Looking at W, this has 3 rows and 1 column, so this would be 3 by 1. X has 1 row but 4 columns, so this would be 1 by 4. And Y is also 1 by 4. And that's order. Now order, like I said, is really just the dimensions of the matrix. Now we can identify specific entries, specific values in the matrix using subscripts. So in the subscript, the row comes first, and then the column comes second. So I have some examples of matrices here, E, F, G, and H. So if I ask for what E12 is, that's saying in matrix E, what is the value in the first row, second column? So E, first row, second column, -1. And that's all that is. F of 2, 2. So F, second row, second column, 3. E of 3, 2. Third row, second column, -2. G, 3, 1. So that's row 3, column 1. That would be 0. H of 2, 3. So the value in the second row and third column of H, that would be 1. And F, 1, 1, first row, first column, -5. So that's how we identify specific values within a matrix. Now, there may or may not be a comma here. Sometimes it'll just like E12, no comma. It really looks like E12. So you need to know, oh, that's saying first row, second column. Now, matrices are closed under addition and subtraction. What that means, if you add a matrix to a matrix, you'll get a matrix. You're not going to get a number or a linear equation. If you add a matrix to a matrix, you get a matrix. Now, in order to add or subtract matrices, matrices must have the same order, or they're not able to be added or subtracted together. Now, to add or subtract matrices, all you need to do is add the values in the corresponding entries. So if I have these two matrices here, both of these have one row, two columns, so they're both 1 by 2. So that allows me to add them together. I would add the first entry of each. 5 plus 20 would give me 25. 4 plus 30 gives me 34. That's how this works. If you look at this next one, 1, 1, the entry 1, 1 for both of these. 1 plus 2 gives me 3. 0 plus 4 gives me 4. 0 plus 1 gives me 1. And that's how we do these together. It's the same for addition and subtraction. You just add or subtract the corresponding entries of the matrix. So looking at letter A here, if I want to add these two matrices together, notice how they're both 3 by 2. So I will get a 3 by 2 matrix for my answer. So I would start by saying 5 plus negative 11. Well, 5 plus negative 11 is negative 6. 2 plus 0 is 2. 4 plus 7 is 11. 9 plus 1 is 10. 10 plus negative 6 is 4. Negative 3 plus negative 8 is negative 11. And that's that. So that would be the sum of these two matrices. Notice it's another 3 by 2 matrix. Subtracting, we do the same thing. We just need to be careful with our order here. So 7 minus negative 3 would become 7 plus 3. That is 10. 3 minus 0 is 3. 5 minus 8 is negative 3. 9 minus 1 is 8. Negative 2, 11 minus negative 3 would become 11 plus 3, which is 14. Negative 2 minus negative 4 is 2. Negative 2 plus 4. And there we go. That would be our difference there. All right. So that's addition and subtraction. We're going to talk about some multiplication a bit. And we're going to start by multiplying by a scalar. So when you multiply a matrix by a scalar, you just simply multiply each entry by that scalar value. A scalar means like a number. So if I multiply a matrix by 3, I would multiply the matrix A, in this case, this 3 by 2 matrix here. Each entry gets multiplied by 3 to give me my value. So let's do some examples here. So looking at letter A, they're saying 3 times E. So this would be 3 times the matrix 1, negative 1, negative 2, 0, 1, negative 2. So I'm going to multiply each of these values in this matrix by 3 to get my new matrix. So 3 times 1 is 3. 3 times negative 1 is negative 3. 3 times negative 2 is negative 6. 3 times 0 is 0. 3 times 1 is 3. And 3 times negative 2 is negative 6. And that would be my answer. All right, looking at letter B, 1/2 times H. So basically I'm taking this matrix H and multiplying everything by 1/2. When I multiply by 1/2, that's the same thing as dividing by 2. So with that being said, 1 divided by 2 is 1/2. 2 divided by 2 is 1, and then 3/2. And then 1, and 3/2, and 1/2, and 3/2, and 1/2, and 1. That would be 3, or letter B here, 1/2 times that matrix H. So now notice I'm multiplying it by 1/2. You actually cannot divide matrices by anything. So anytime you want to half a matrix, instead of saying divided by 2, you would need to say multiplied by 1/2. That's an important thing that we'll talk more about here in a sec. So looking at letter C here, 2F. So I'd take matrix F and multiply all of the values in it by 2. So negative 5 times 2 is negative 10. 2 times 2 is 4. Negative 1 times 2 is negative 2. 2 times 3 is 6. 2 times 4 is 8. We got negative 8. There we go. D, negative G. So think about this. This is the same as negative 1 times the matrix G. So negative 1 times G basically means I'm flipping all the signs in G. So I'd have negative 1, 0, negative 1. G is over here just to make sure. Negative 3, positive 1, positive 2, 0, negative 2, positive 1. There we go. Fantastic. All right. So that's multiplying by a scalar. Now, I want us to try a couple on our own. Let's see. Let's do one of these together, then I'll have you try one on your own. So let's look at letter A. Let's do this one together. basically we are subtracting and adding matrices together. Now matrices can follow the order of operations. So I would do the subtraction within the parentheses first and then add it to this matrix. So let's start with the subtraction. So 4 minus 6 is negative 2. 0 minus negative 2 would become positive 2. Negative 1 minus 3 is negative 4. 5 minus 4 is 1. So that's what I get from the subtraction here. Now I'm going to add that to 3, 5, negative 1, 8. And that will give me negative 2 plus 3 is 1. 2 plus 5 is 7. Negative 4 plus negative 1 is negative 5. 1 plus 8 is 9. And that would be my final answer there. All right, so we did letter A together. Why don't you go ahead and pause the video, try letter B on your own, and then we'll check it together, all right? Go ahead and hit pause, try letter B on your own, and then we'll check it together. All right, let's check in with letter B here. Let's see how we did. So first thing I'll need to do is this subtraction. So I'll say negative 3 is going to be multiplied times whatever I get from the subtraction. So 1 minus negative 6 is 7. 4 minus 4 is 0. Negative 2 minus 8 is negative 10. 3 minus negative 1 is 4. Negative 1 minus 3 is negative 4. 7 minus negative 2 is 9. Negative 4 minus negative 5 would be negative 4 plus 5, which is 1. 6 minus negative 3 is 9. 5 minus 2 is 3. Now from there, I need to multiply all of these values in this matrix by negative 3. So I would now have negative 3 times 7 is negative 21. Negative 3 times 0 is 0. Negative 3 times negative 10 is 30. Negative 3 times 4 is negative 12. Negative 3 times negative 4 is positive 12. Negative 3 times 9 is negative 27. Negative 3 times 1 is negative 3. Negative 3 times 9 is negative 27. And negative 3 times 3 is negative 9. And that would be my final answer there. Excellent. All right, hopefully we're feeling good about that. The next thing I want to talk about is we can actually solve for variables within a matrix. And there's a couple of different ways to do it. We'll do letter A together, and then I'll have you try letter B on your own. Looking at letter A, the first thing we have to identify is the variables. And what we're going to do now is we're going to create equations using those variables. So looking at here, I have an x, I have y. Those appear to be the only variables in this expression. So that's going to be what I solve for. And I'm going to create an equation using the values that are in the same locations in these matrices. So notice my x is in the first row and first column of each matrix. So let's create an equation using the values in the first row and first column of each matrix. So I would have negative 2x plus 2 times 5 equals, first row, first column, negative 9. All right, so that means negative 2x plus 10 is negative 9. Subtract 10, negative 2x would be negative 19. So x will equal 19 halves. And that's our value for x. Now there's also a y in the second row and second column. So let's create an equation for that. So negative 8 plus 2 times 6 equals y. Well, negative 8 plus 12 would equal y, which means that y would equal 4. There we go. Notice they're not coordinates. We don't write them as a coordinate pair or anything like that. We're just solving for variables. Now, I want to do one thing first for letter B before I let you try it on your own. Notice there's a variable outside of the matrix. And if that's ever the case, you have to solve for that one first before you do W, Y, Z here inside the matrix. So in order to do that, we have to find a value in these matrices that don't have a variable, a location that doesn't have a variable. So notice how the first row and first column of each matrix doesn't have a variable. So we can use that then to solve for x. So I would say 4x times negative 1 equals 8. So that means negative 4x equals 8, which means x equals negative 2. And now that I know x is negative 2, what I would recommend doing is go ahead and rewriting this with negative 2 plugged in. So 4 times negative 2 is negative 8 times the matrix negative 1 2, 3w, 6 equals the matrix 8, negative 2z, negative 24, and 3y. All right, from there, I'm going to let you go ahead and try to solve for w, y, and z on your own. Go ahead and try to solve for w, y, and z on your own. Pause the video, and then we'll see how we do. All right, let's see how we did. So for w, y, and z, we needed to create 3 different equations. So let's start with this equation for w. So it would be negative 8 times 3w equals negative 24. So I would do negative 8 times 3w is negative 24w equals negative 24. Divide by negative 24, divide by negative 24. And we find here that w equals 1. Fantastic. What about y? So negative 8 times 6 would equal 3y. Negative 8 times 6 is negative 48. It's 3y divided by 3. Negative 48 divided by 3 is negative 16. So y equals negative 16. What about for z? Well, we would have negative 8 times 2 equals negative 2z. So that'd be negative 16 is negative 2z divided by negative 2 divided by negative 2, and that means that z equals 8. So from that, we've found that x is negative 2, w is 1, y is negative 16, and z is 8. And that's how we can solve for variables inside of a matrix. We just create individual equations using the values in the same location of the matrices. All right, next we're going to talk about multiplying matrices by another matrix. And this is definitely where we will need our calculators, so go ahead and get those out if you haven't already. Let's make sure we can turn this one on. Very good. All right, so let's say we're multiplying together 2 matrices, A and B. In order for the matrices to be multiplied together, the number of columns in A must equal the number of rows in B. That is a huge thing for you to know. All right, so let's say I have matrix M times N, and I want to multiply it by a matrix something times Q. In order for that to be possible, the number of rows in this matrix must be N, okay? If I were to write it out like this, these two values have to be equal, right? These are the orders of the 2 matrices. So let's talk about how we can use our calculator to do this. We are not going to do this by hand. There is a way to do it by hand. It is long and kind of convoluted though, so we're just going to use our calculator to multiply matrices. First, to input a matrix, I need you to hit second and then this button right here, matrix. See how it says matrix above there? All right, and what it does here is it gives you a table of matrices. In order to edit the matrices, you need to go over to edit. And then you can press enter, and we're going to change matrix A to be this matrix here. All right, so I'll press enter. Well, what is the order of this matrix? It's 2 by 2. So I need to make sure that this says 2 by 2. And then notice how many spots I have. 2 rows, 2 columns. So let's plug in our values here. 4, and then I press enter, and that moves me to the next one. 1, enter, negative 2, enter, and 3. Perfect. All right, and now it's very important to get out of this. You hit second, quit. All right, you can't hit clear because that'll change the value in there. You have to do second, quit. So now let's do that again. Second matrix, we're going to edit now matrix B. Matrix B is a 2 by 2 matrix, so that's already in there from last time. So now I need negative 1, enter, 2, enter, negative 4, enter, and 3, enter. Second, quit. All right, now to actually perform the multiplication, I'll hit second matrix, and from the names column, I'll select A, just press enter, and then I'll second matrix, go down to B, press enter, AB equals, and here we go. AB, negative 8, 11, negative 10, 5. So I would say -8, 11, -10, 5. And that's exactly how I would write it. Now let's find BA. So to do that, I would need to type B first. So B now times matrix A. Enter. Look at this. -8, 5, -22, 5. What do you notice? Look at what we got for AB. Look what we got for BA. They're not the same. All right. This is a huge part of matrix multiplication. AB will not necessarily equal BA. This means order matters. The order in which you multiply matrices absolutely matters, okay? Okay, order matters. AB is not the same as BA. They are not associative like that. All right, so let's say we're multiplying together two matrices, A times B. We have matrix A, B. Now the order of the matrices is M times N and N times P. First, notice that we can multiply these together because these are the same. A cool thing is that the order of AB will be the number of rows from A and the number of columns from B. So the order of matrix AB will be M by P. All right. So we're going to practice this pretty extensively, okay? So let's go ahead and scroll down a bit. Here's what we're going to do. We're going to use these matrices for numbers 3 through 8 here, all right? So first, we're going to A, determine if the matrices can be multiplied together. B, if the matrices can be multiplied together, state the order of their product. And C, find the product of the matrix multiplication. So A, B, C, we're going to do these for all of these problems here. All right, so let's start then. Let's look at number 3, tells us to do A times B. A, B. Matrix A, matrix B. Okay, so first determine if the matrices can be multiplied together. So A times B is asking us to do a 2 by 2 times a 2 by 3. All right, so are these numbers equal? Yes, they are, which tells us yes, they can be multiplied. If the matrices can be multiplied together, state the order of the product. So the order, remember, is the outside terms from this. So 2 by 3, the product then will have an order of 2 by 3. All right, C, find the product of the matrix multiplication. So what I'm going to do here, this is the same matrix A as above, 4, 1, -2, 3, 4, 1, -2, 3. So I don't need to retype that in. However, this is definitely a different matrix B. So let's change this up here. So I need to do second matrix. I'm going to go over to edit, and I'm going to edit matrix B. I'm going to change this to a 2 by 3 matrix because I have 3 columns now. So I will have 2, 1, -3, and 4, 0, and 6. There we go. All right, second quit. So now I'm going to do second matrix. I'm doing A. Oh, sorry guys. Let me get rid of that real quick. All right, and B. Second matrix B, which is now the 2 by 3 matrix there. And when I multiply it, notice I get a 2 by 3 matrix for my answer. So let's go ahead and write this in here. We'll have 12, 4, -6, 8, -2, and 24. And there we go. Fantastic. So that's how we're going to do these for 4, 5, 6, 7, and 8. So let's do letter number 4 here, B times C. So let's look at this one. B times C is a 2 by 3 being multiplied by a 3 by 3. Oh, sorry. So are these middle numbers the same? Yes, they are. Awesome. So a 2 by 3, so yes, we can multiply it. It will become a 2 by 3 matrix. Let's do it. So notice B I already have typed into my calculator. I don't need to change that, but I need to change now matrix C. So matrix C is a 3 by 3 matrix of -1, 3, 2, 1, 0, 4, 2, 1, 6, and then I second quit, second matrix B, enter, second matrix C, enter. All right, and we get that 2 by 3 matrix as our product here. So let's write this out. -7, 3, -10, 8, 18, 44. Beautiful. All right, now since we're doing all of this in the calculator, it's really important that we take our time to make sure these values are correct that we're putting in. Because obviously, you know, we're just assuming that these numbers are correct, but they're all based on the values that we place into those matrices. So making sure we're taking our time with those. All right, so let's do number 5 together now, C times D. So C is a 3 by 3 matrix. D is a 3 by 1 matrix. These middle numbers are the same, so we can multiply them. Yes, the order will be the outside, so 3 by 1. And let's do it. So I need to second matrix, I need to edit matrix D here, so it becomes this matrix here. It is a 3 by 1 that has the order of 3, 1, 2. So shout out to Chicago. All right, so second quit, second matrix, I'm going to do matrix C, second matrix D. Very nice. 4, 11, 19, that 3 by 1 matrix. What do you know? 4, 11, 19. Beautiful. All right, now let's look at matrix. This one here, letter 6, D times E. Well, matrix D is a 3 by 1. And matrix E is a 3 by 2. So looking at the center numbers, are they the same? No, they are not. This is 1, this is 3. So that means we cannot multiply these matrices here. And all we'd say is, you know, no solution. It's impossible. Can't be done. And that's it. That's it for there. All right. Why don't you guys go ahead and try number 7 and number 8 on your own? All right, so go ahead and pause this video, try number 7, try number 8 on your own, and then we will check them together, okay? Pause video, 7 and 8 on your own. All right, let's go ahead and see how we did for number 7 and 8. So looking at 7, we have B times E. B is a 2 by 3. And E is a 3 by 2. So are the middle numbers the same? Yes, they are. So we can multiply them together. Now notice the outside numbers will give us that order. So this will become a 2 by 2 matrix. And now I need to insert E into my calculator. So I'm going to do second matrix, edit matrix E. So E is a 3 by 2 matrix, rows by columns. So 4, 2, 3, 0, -1, and -3. Excellent. So second quit, second matrix, and I am doing B times E. So I'll go down to B, press enter, second matrix, go down to E, press enter. 14, 13, 10, -10. That 2 by 2. 14, 13, 10, -10. There we go. All right, last one, D times F. Well, D is a 3 by 1 matrix. F is a 1 by 4 matrix. All right, so are the middle numbers the same? Yes, they are, so that means we can multiply these together. The order is going to be a 3 by 4 matrix. So let's type in F into our graphing calculator here. So I'll do second matrix, edit, go down to F. The order of F is 1 row by 4 columns. So I will have 1, 2, 5, and 1. Second quit. And now for this multiplication, I'm doing D times F. So I go second matrix D, enter, second matrix F, enter. And here is that 3 by 4 matrix here. All right, let's write this all out. So we have 3, 6, 15, 3, 3, 6, 15, 3, 1, 2, 5, 1, 1, 2, 5, 1, 2, 4, 10, 2, 2, 4, 10, 2. Beautiful. And there is multiplying matrices by a matrix. Fantastic. The last thing I want to talk about today is the identity matrix. And the identity matrix is based on the multiplicative identity. And basically what that means is if I multiply any number times 1 or 1 times any number, I get that original number. The identity matrix in this case is what 1 represents in the matrix world. All right, so in the matrix world, the identity matrix is the same thing as 1. If you multiply a number by if you multiply a matrix by the identity matrix, you'll get that original matrix you multiplied by. So the identity matrix is a square matrix with 1s on the main diagonal and 0s for all other entries. Now, you're probably wondering, Mr. Carter, what the heck is the main diagonal? The main diagonal is, let's say we have a matrix like this. Now remember, this is a square. The main diagonal is the diagonal that goes from the top left to the bottom right. All right, that's the main diagonal. Now the identity matrix is always named with a capital I and a subscript showing its order. Now remember, square matrices only have one value. You'd say it's a square matrix of order 4, of order 5. That means it's 5 by 5 or 4 by 4. All right, so let's write the identity matrix here. So I of 3 would be identity matrix that's 3 by 3. So a 3 by 3 square with 1s on the main diagonal and 0s everywhere else. That is the I3 identity matrix. I5 would be a 5 by 5 square. I'm going to have a lot of space here with 1s on the main diagonal and 0s everywhere else. 0, 0, 0, 0. Lots of zeros. 0, 0, 0, 0, 0, 0, 0, 0. There you go. There's the I5 identity matrix. I2, a 2 by 2 matrix, like so. And the cool thing about the identity matrix is how it interacts with other matrices. So I want to show you this, and this will be the last thing we do today. So here's matrix A. It's a 3 by 3. Find AI. So not artificial intelligence, just A times I. I'm not trying to have you take over the world here with some computers. All right, find A times I. So that would be 1, 2, 3, 0, negative 1, 2, 2, 2, 1 times I3 in this case, right? Because it has to have the same order. So 1, 0, 0, 0, 1, 0, 0, 0, 1. And that's going to be what I type into my calculator. Now, we can't really get down to I in our matrix idea here. Maybe it does. I don't think it did. Oh, there's I. So if you want to type in I as the identity matrix, heck yeah, let's do it. Why not? I is going to be a 3 by 3 of 1, 0, 0, 0, 0, 1, 0, 0, 0, 1. Enter. Second quit. Now, oh no, let me get rid of this. Sorry about that. So now we need to change matrix A here. So second matrix, oh, wrong button. Second matrix A is going to change. I'm going to hit edit, and it's going to become a now 3 by 3 matrix of 1, 2, 3, 0, -1, 2, 2, 2, 1, enter. Second quit. So I'm going to find A times I. Second matrix A, second matrix, go down to I, enter. Notice this is the same thing as matrix A. I get the original matrix A because I'm multiplying it by that identity matrix. So 1, 2, 3, 0, -1, 2, 2, 2, 1. Now, if I multiply a number by 1, that's the same thing as multiplying 1 times that number. Let's see if that holds true in this case. So in this time, I'm going to do second matrix I and second matrix A. What do you know? I do get the same thing. All right, so the identity matrix is a rare example where the order does not matter. All right, I times a matrix is the same thing as a matrix times I. Now I want to stress, remember, that is not always the case. The order of multiplication matters unless you're dealing with the identity matrix. Then it doesn't matter if it's the first factor or the second. All right, that's it for today. I apologize for the long notes, but that was a lot of information to get through. I hope you all are feeling happy, safe, feeling good. Let me know if you have any questions. Feel free to send me an email. Otherwise, the practice problems are posted on the Teams page. Go ahead and get started on those. If you have any questions, keep checking your email. I'm sure we'll have some more meetings coming up soon where we can talk face-to-face virtually. Mr. Carter, signing off. I'll see you guys next time.